Good morning, I'm on site here at Embedded World 2022 and joining me today is Brian from Texas Instruments and Drew from PHYTEC America. So thank you both for joining us today.
Thanks for having us.
Now we're going to be talking about building a smart EV charging station. So let's start by talking about how is TI reducing the size of its portable DC chargers?
Yeah, so I mean, from our perspective, a portable DC charger, right, is essentially a battery pack or multiple battery packs in parallel, right? And so on the EV side itself, we have battery management systems for 4, 8, 16 series batteries. Those are sensing, doing load balancing, right, and then sending that communication wirelessly to manage the entire system. So when you extend that over to a portable DC system, you know, that's one way, wireless communication, sensing technology, and then obviously the size of the FETs, the efficiency of the FETs, right? Whether it's silicon carbide, gallium nitride, right? Whatever you're selecting, it's getting it into the most efficient process possible and the smallest package size. So really optimizing at every point, right?
Yeah.
Because the cells themselves, you know, it's not driven by the silicon technology.
Of course, fantastic, thank you. And so what are the key devices in TI's embedded technology for EV chargers?
Yes, if you look at the EV charging demo at the TI booth, the brains of that solution, or the gateway, is the Am62 Mpu. So we just released that a couple weeks ago. The Am62 is low cost, low power, easy to use device that's enabled by our partner here, PHYTEC, in the demo. And within that, we're highlighting the Y-Link WL1837 module for Wi-Fi and Bluetooth. And then we actually had a demo at CES using the CC1352P7, which is approved for Wi-Sun, right? So the communication between the charging stations would be potentially managed by Wi-Sun or one of the other low power communication protocols. I think that's from the embedded side, that's it. And then we have the analog reference design. So in this demo, it's level 2. You know, in the next demo, maybe it'll be level 3 DC charging. And yeah, True wants to talk a little bit more about the SOM and carrier board solution that we put together.
So what PHYTEC did is we actually partnered up with TI to take that Am62X processor and modularize it and make it as easy as possible to design into new and novel designs. So what we call is a system on module. It's a very small PCB like this with very high density connectors, very robust, very industrial grade focused. And what we do there is we take that system on module, then we integrate it into a baseboard, what we like to call a carrier board, with the mating connectors there that enable you to just plug and play that SOM into that baseboard and then easily integrate it. It's an OEM-able product, but what PHYTEC likes to do is also provide design services such that we can create custom boards, custom to the application. In this case, for the EV charger, we just utilize the development kit carrier board, but it could be cost optimized and customized to your unique application. And we also provide a Linux distribution as a base reference, which we've also utilized here. And our development kit also enabled the integration of the touch display for the HMI interface.
Brilliant, some fantastic features there. Okay, so following on from that, how important is GaN technology?
Yeah, so I was actually talking to our experts over at the onboard charging demo at the TI booth, and so their opinion of GaN is, it is obviously very important, but it depends on the voltage and the total power. So within TI, we have gallium nitride solutions, we have silicon carbide FETs, and the solution over there is a 400 volt system. So what we've seen is that within the 400 volt system, you're using a 650 volt gallium nitride FET. I think it's like 30 milliohms. At that voltage, GaN is the most efficient. And so you're taking that, what it would be with silicon carbide, it's 30 to 50% smaller size volumetrically with the GaN solution. But if we were to do an 800 volt system or higher power, like 11 kilowatts, I think is the European standard. We're Americans, so I don't know. But I think the European standard is 11 or even 20 kilowatts. At those power ratings, we've seen silicon carbide is more effective. So, you know, it really depends, but obviously GaN and silicon carbide are going to be used a lot more across different systems.
Yeah, definitely, fantastic. So what is the capacitance required for EV chargers to enable faster charging?
You know, I thought about this a lot, and I wasn't sure what you meant by the capacitance. So the capacitance really, I look at it as the battery itself is acting as a capacitor,
Yeah.
right? And so when you look at a DC wall charger, the beauty of the DC wall charger is you bypass that AC to DC conversion in the EV itself, and you're just directly charging the battery. So you have less losses, less charging that you need to do in the onboard capacitance. And so the way that you optimize that is essentially stacking the DC in parallel. So you push that off to the grid side, do AC to DC conversion here, AC to DC conversion here in multiple steps, and then that really allows you to push as much into the car as you can. So, I couldn't tell you a number on the capacitance.
Fine, I'll let you off. Fantastic. So how can semiconductor technology help to manage energy distribution through smart energy metering, and what are some of your solutions?
Yeah, so what I was mentioning earlier with the Y-Sun and even what the PHYTEC had done with the module itself sits on the carrier board. Behind that, we have the Y-Link module with an M.2 card.
Right.
We also, I think Sam, the designer, created a CC1352 M.2 module as well. And so it's kind of an either or, right, in terms of communication, but the idea being that whatever method of communication, Ethernet, Wi-Fi, sub-1 gig, Bluetooth, whichever method of communication you're choosing, that you're trying to manage the balancing between all of the charging stations on that network, right, and the grid as a whole. So, the embedded technology, I think it varies by region, what method of communication is preferred, but it's making the system more efficient, making sure that the car that needs it the most is getting the right amount of charge, or I think back to the grid is one option as well with the bidirectional charging.
Yeah, fantastic.
Safety is also another very important thing that I probably want to chime in here real quick about.
Sure.
With the integration of PHYTEC's development kit. We also included a Codico Red Beat board module, which is actually facilitating the PLC or power line communication between the charger and to the car and back to enable that safety. And I can't remember the exact the standard, but these standards vary depending on where you are.
So the initial pilot wire communication has been used for a while. I think it's the IEC 61581. And so on top of that, you have the ISO 15118. So that's the amount of charge, the charge state of the vehicle, and then what it's rated to.
Fantastic. Okay, so following on from that, how are TI helping to build bidirectional charging, which enables the consumer to send power back to the grid, which you've sort of mentioned earlier?
Yeah. So the bidirectional charging is enabled by the vehicle to grid capability, right? And so, or vice versa, right? So the way that works, right, is all the solutions that we have on TI.com, that communication back and forth allows you to essentially sell back to the grid. No one's donating anything, but sell that back to the grid. And so that's enabled, obviously at the analog level, pumping that current, that power back into the grid, as well as communicating as to what your capabilities are.
Yeah, brilliant, fantastic. Question for you now, probably. So how are TI's new ARM-based Am62X processors enabling simpler and easier payment for EV charging?
Easier payment? Well, it's a very general purpose platform, and by its nature, it runs Linux by default. At least that's like the standard offering from TI, and that's also what we support at PHYTEC. And so with Linux, the possibilities are pretty endless. And so in this case, I think utilizing the Linux drivers and the stack there that's included, we are able to utilize the Y-Link module for Wi-Fi, and then you can enable payments through your phone, and things like that are via apps and things like this.
Yeah, and so one of the things that we add on to the system, it's in all in pieces, right? So that you're not dedicated to one type of system.
Right.
So
It's very modular.
yeah, the system's very modular. So we talked about the Wi-Fi versus the sub 1 gig and the BLE. In this case, you have the option to add in an NFC card reader, and then the display capabilities of the device give you that interface. So in places where you have tap credit cards, so you again with the mainline Linux, you can pull in the driver of the NFC device, pull it into the package, and the payment systems themselves typically can run on Linux or Android, which is supported for Am62.
Fantastic, sounds very simple. So how is TI working with Digikey to implement EV charging technologies? What support does TI give to Digikey customers?
Yeah, so I think one of the big things coming into this with a big launch like the Am62 Mpu was enabling customers to use our devices through the ecosystem. I know Digi-key carries, obviously, BeagleBoard, which we see them previously in the sessions and walking around the booth constantly. So BeagleBoard, right, has been a partner for a long time, and PHYTEC has their system on module. I believe Digi-key carries all of the current
development kits on Digikey as well. So.
Fantastic.
And we also buy parts through Digikey, so it comes around. It's a circle.
Full circle, yeah. So
Brilliant.
enabling that ecosystem, getting customers to see how they want to put the pieces together and what offerings they need. I feel like you might be asking us to do some more like white papers and sessions with you, so we're definitely open to the idea.
Fantastic. I'll hold you to that. Brilliant. Well, thank you both very much for your insights today. It's been a pleasure speaking with you, and enjoy the rest of the show.
Thank you very much.
Thank you. Thank you.